going to go to 7-4, you should already have all this written down. Uh-oh, I just graded notes. I just graded notes. And remember how if I didn't see a section number and a section title and actually all the notes we took that day, I took off points?
Yes.
So if you don't have this and I move past it, you better find it online. You better find it online and copy it, or else you're going to lose points on notes again. We are looking at the opener real fast that you guys tried at the beginning of class while I was grading notes. You guys had plenty of time to talk at the beginning. We'll go back in a second, but we're looking at the opener right now. You guys had plenty of time to talk, so now it's time to focus. Yeah? Here we go. What was in common between 42 and 70 was 14, but most of us wouldn't have seen that off the top of our heads. Did any of you guys know 14 goes into that and that? No, we don't think like that. Some of you guys would have. Armando, you need to be focused. Some of you guys might have figured out that a 2 goes into both because aren't both numbers even? Okay, so we could have said, hey, 2 goes in, and if you factor out 42 and if you factor out 70, there is a 2 that's in common, but what else was in common? A 7. So 2 and 7 were in common, so 14 was the GCF. Now, 20 and 36. Maybe you guys didn't need to actually write out all of the different factors, which you could have gotten by the factoring tree for each one. Does anybody know what the GCF is? You were trying this at the beginning of class, just off the top of your head. No, but what is it for these two numbers? What's the answer? 4? 10 does not go to 36. That's awkward. So if you were to break down 20, you would end up breaking it down, getting 2 times 2 times 5. And 36, you would get 2 times 2 times 3 times 3. What was in common were 2 2s. That's it. Everything else doesn't match. So there was a 4 that was in common. Now some of you can see it just by, oh yeah, 4 goes into 20, 4 goes into 36, nothing bigger does. That's one way of seeing the GCF. But remember, up here that wasn't enough. 14 would have been really hard for all of us to figure out. Now down here for 30 and 77, do you guys see right away that there's a variable that's in common?
X.
Yeah, the common variable is X, but what we have to ask ourselves is there a number that's in common? How do you know that no number is in common?
7 and 11. There's no numbers in common.
70, but why? 77 is 7 and 11. Does 7 go into 30?
No.
Does 11 go into 30?
No.
So don't even worry about looking. The GCF is only the X. That's the only thing. Now, I left a big space just in case there was a number part. Sometimes there is, but there wasn't in this one. But as we go down to number 4, ooh, I think there might be a number in common and a variable in common. All right, Armando, go ahead and put it on my desk. There might be a number in common and variables in common. Do you guys, let's look at the variables first, then we'll go back to the numbers. How many variables are in common?
2.
Yeah, but don't write 2x. Isn't it technically an x times an x, so x squared that's in common? Do you see it? If we were to write out this guy, and if we were to write out this guy, just the variable part, wouldn't he have x times x times x, whereas this guy would only have that twice?
Yes.
So they have shared an x squared.
Oh, I get it.
See it? They have shared an x squared. Now he has an extra x, but okay, what's shared? Now hold on, we have to figure out the numbers. 2. Does 2 go into both?
Yes.
But couldn't something bigger go into both?
Yes.
Okay. So then some of you will go looking for, does 4 go in? Does 6 go in? Does we could start asking ourselves and dividing in a calculator and going bigger and bigger, trying to find the right number. But the other way is we could take, if it's like, that's like a guess and check. Maybe we'll get it, maybe we won't. We could also do something like, you know what, I think 4 goes into both. Let's try it, and you could get, let's see, 1 and 18 times, and 4 goes into this one 21 times. 2 goes in, yeah. Does 4 go in? You could divide and say, it does go in. Now, we better keep looking. Does anything else go in? We have 2 and 9, and we have 3 and 7. Oh, those are different. But wait, what do you see?
3 and 9.
Doesn't 3 go into 3 and 3 go into... Okay, so hold on. If we were to try to write this all out, we would get 4 times 2 times 3 times 3. This one would get 4 times 3 times 7. Isn't there a 4 in common and a 3 in common?
Yeah.
It's hard when the numbers are big, but oh, well, if we break it all down, maybe we can see there's a 4 in common, there's a 3 in common, so what's my common number?
12.
I can divide 72 by 12. Oh, we should know that. 12 goes into 72 6 times. 12 goes into 84 7 times. It's okay. Even if your brain didn't tell you right away, we could break it down and find what's in common. So G, C, F, what is in? G, C, F, what is in? Common. Yeah. What is in common? And try to find the greatest one. All right, all my little ear pods hiding behind here. Take it out real fast. I'm not looking for a second, but I'm seeing them. Get them out or else I confiscate them. All right, moving on. So let's go to notes. Moving on, let's go to notes. Section 7.4b. Section 7.4b. Some of you started this, some of you didn't, but all of us should be taking notes now, especially if we haven't taken them yet. We are trying to factor out GCFs of binomials or trinomials, or maybe even bigger ones, which are polynomials. And the goal is to undistribute. Wait, undistribute? What's distributing? It's the multiplication thing, right? Isn't distributing when you have a number on the outside and you're trying to take it in? Distributing. It's what those of you that did arrows were thinking of when you were stop, focus, foiling. Even when you were doing a table, you were distributing, just you didn't quite see it the same way. So, what is undistributing? Undistributing is looking at something that's all together, no parentheses, no need to multiply, and going backwards and saying what is in common and how do I take it out? So instead of going from the top to the bottom, we're going from the bottom to the top. We're asking ourselves, is there anything in common? In that one, it's a 5. But look at this one. What's in common in these two terms? 4. And what else? Well, yeah. But 4 is the greatest one, right? So if we're trying to find the GCF, 4 is good. That's the biggest number that goes in. But what else? X. How many x's though? It's not just 1 x.
3.
So wouldn't I write x to the power of 3? Because there's x times x times x in common. So we ask ourselves, what is the GCF? Well, actually, this is step 1. Figuring out the greatest common number and the greatest common variable. Sometimes it's both. Sometimes it's just a variable, sometimes it's just a number, and sometimes there isn't one. What's in common? Now, here's the hard part. Not just finding what's in common. That's what the opener was. But taking it out. What's in common of each of these?
5.
We now need to put parentheses and take it out. We need to factor it out is what it's called. So factoring it out, what you guys need to think about is parentheses. Taking your original expression, I always put the plus, that way I don't forget. There are 2 different pieces. And I need to pull out the greatest common factor. What would have been here before the distribution happened? We're working our way backwards. So we always take the GCF and we write it in front. We always take the GCF and we write it in front. But as we write it in front, what allows us to do that, wait a minute, hold on. If multiplication, this is so important in algebra, guys, and this is just the tip of the iceberg, the easiest types of problems of a huge topic called factoring. Something that anyone who ever takes algebra is like, oh, yep, that was a part of algebra, factoring. Look at it. This is multiplication, right?
Yeah.
Multiply, multiply, multiply. Distribution is multiplication. So if we're going backwards from multiplication, think algebraically, what operation would be involved if I'm going backwards from multiplication? Division. So Jeremy, check it. If going backwards from multiplication is division, I need to take the original expression, 4x to the 4th, and 24x cubed. And anytime I'm factoring, I'm dividing. Now I know it's going to look really nasty for a whole 2 seconds. It's going to look really nasty for a whole 2 seconds because I'm saying I'm taking him and I'm pulling him out. But when I pull him out, I'm undoing multiplication. I'm dividing. Now this looks nasty. This looks nasty. But a shortcut that we're going to hopefully get better at is in our brains doing this division and not having to write it. We're undoing the multiplication by factoring. We're dividing. Now check it. Here's my question. This could be really hard or it could be really easy. If I take away from 4x to the 4th, if I take away the 4 and x cubed, what is left?
X.
Just 1x and just a 6. Nice.
That's right. That's true.
That division is just asking what's left. When you take away, if I was to write out the 4x to the 4th, and if I was to write out the 24x cubed, if it was one of those really hard ones, I would have a 4 and then 1, 2, 3, 4. I would have a 4 and a 6 and 1, 2, 3. If I divide a 4 and x cubed, what's left? One little baby x. If I divide or take away a 4 and x cubed, what's left? A 6. So if you think about each of these as being all written out, separate pieces, I can say, okay, when I factor, I have to take away each of these guys from each one, each term. That's called factoring out the GCF. Now we're going to look at the purpose and why we're doing this in just a second. But Jeremy, go ahead. What's up? Oh, you were? No? Okay. So, ready? Just you. Complete silence. What is the GCF? And what would the factored form look like when you pull that GCF out? You yourself and you with your best guess. Here's our original expression. Who would the GCF be between these two guys? And when I pull him out, what would be left? Go. Write down the original expression. The goal is to factor out the GCF. Who is it? 7.4 feet. 7.4. We already did that. Now we're doing before you can pull them out, you have to think about who it is. What's in common? What would the GCF be? I got one right in.
All right.
Good. That's your GCF. Now here's your thing. If you pull that in front, if you pull it away from each one, what's left? What's remaining? Who's figured out the number that's in common? An 8. A 2 is, and a 4 is, but the biggest one is 8.
8.
Right? I know, you wrote it down, right? A 2 goes in, a 4 goes in, but the biggest one is 8. That's the biggest number in both. But what's the biggest variable? I can't say y squared, he only has 1, so just 1, right? 8y is in common. So what am I trying to factor out is that 8y.
Oh, I get it now.
And when I factor him out, I'm asking myself, technically, I'm dividing and saying, I gotta take that 8y away. When you pull it out, you're taking it away and asking yourself, what is left? So the 8y is in front. Some of you don't even need to write the division, but that's technically what you're doing. When I take away the 8 and I take away 1y, what's left? 1y. Minus, take away the y And 24 divided by 8 is
4. I'm in 3. Wow.
There you go. Woo! All right. We're pulling out a GCF. We're pulling out a GCF. But here's how we have to end class. The question is, why? Do you remember on your test that you took yesterday? Or in class, and I talked about Moses in the Red Sea? Or God being free Moses? What was the purpose? We had these equations where we had an equation equals 0. The first step was, is it equal to 0? All of ours were in 7.4a. The second step was, is it in factored form? And if it was, we were able to take each factor, split them up, and set each one equal to 0 and solve it. This is not in factored form. This is. These are the harder types of problems that we skipped in section 7.4 to make it easy for the test yesterday. So here's what we need to do to finish this section. We need to think about, how do we solve, my highlighting got a little too thick there. How do we solve an equation if they aren't factors for us? We make them ourselves. 1A. Nope. Oh, you're thinking GCF already. Good job. But what I'm showing you is this is the point of everything we've done today. In section 7.4, we had stuff equal to 0. And we say, yay, it's equal to 0. But boo, there aren't factors that I can nicely split up. We have to do it ourselves. Before we can split up, we have to ask ourselves, okay, fine. It's not in factored form. I'm going to put it in factored form. What's my GCF?
A.
Just an A. Just one A. That's it. What's left when I pull out the A?
A.
Plus,
5.
took away the A from him, took away an A from him. Now what can I do? I have my factors that I can now split, right? And what do I do once I split my factors?
0.
Set each one equal to 0. And if there's some math I have to do, I do it. Guys, what would A equal if I finish my math?
Negative.
Yes.
So what are you going to face tonight? The equal 0 equations, but they're one step harder because you have to factor them first by finding the GCF. Homework, write it down. Or take a picture. Is it on Runway? On your way out the door, and it's on Runway. I will put it in Google Classroom, and I will post the PDF to notes today. Just in case you guys still want to show it. Thank you. Now it's easy, you're rocking it?
You need to get a harder one.
Okay. I'll work on it.